Welcome back. Today we're going to be talking about probability. Specifically, we're going to be talking about independent and dependent events. Let's take a look at a couple definitions. Now, when we talk about probability, we're talking about two different things. We have independent events and dependent events. So when we talk about independent events, that's where we have two events where the outcome of one event does not affect the outcome of the other event. So an example of this would be if we were flipping two coins, for example, the outcome of the first flip does not affect the outcome of the second flip. The other kind of events that we talk about are dependent events, and that's where we have two events where the outcome does affect the other event. So for example, if I were taking cards out of a bag or cards out of a deck, and I took one and didn't put it back and went to pick another card, well then the probability would be changed because I've taken away cards out of the deck, and now there are not as many as when I started with the first time. We're going to see how this affects each type of probability. So let's talk about how we figure those out. Now we're going to start by determining if something is either dependent or independent. And again, we're going to remember, if the thing is not affected, then we know it's independent. But if it is affected, that is dependent probability. So the first one says we're going to pick fruit from a basket, putting it aside and picking another fruit. Well, when we do this, we've changed the amount of fruit in the basket, so therefore it becomes dependent because we've changed the second outcome. The second one says spinning a spinner and flipping a coin. Well, the outcome of the spinner is not going to affect the outcome of the coin, so that is independent probability. We're flipping the same coin 3 times. Now, although it may seem, hey, if I get heads 2 times in a row, it must be heads the third time, the coins don't actually affect each other. The outcome of one coin doesn't determine the outcome of any other coin, so therefore it is independent events. Picking a marble from a jar, putting the marble back, and picking another marble. Well, in this case, just like the first one, we're taking something out. But in this case, we're putting it back. So since we started with, let's say, 10 marbles, we take one out and we put it back, we still have 10 marbles. The outcomes haven't been changed. So therefore, this is independent events. Taking a donut from a box, eating the donut, and taking another donut, well, obviously, this is going to affect the outcome. If I take a donut out, then the total number of donuts has changed, so the probability has changed, so therefore this is dependent events. And picking a card from a stack, replacing the card, and picking another card, well again, if I had 10 cards and I took one out but I put it back, I still have 10 cards the second time, so this is independent events. Now that we've determined what type of events are, let's take a look at how we figure out each probability. Let's take a look at example A. In example A, it says Andrea needs to roll double 4s to win the game. What is the probability that she will win? So whenever I'm trying to figure out a probability or events, I need to multiply my probabilities together. So I'm going to start by figuring out the first probability and the second probability, and then I'm going to multiply them together. So to roll double 4s, if I'm talking about a regular dice, I know there are 6 sides on a dice, and only one of them has a 4 on it. So the first time she goes to roll one of the dice to get a 4 on it, she has a 1 out of 6 chance. So I'm going to say 1/6. Now again, I'm going to multiply that times whatever the second probability is. So I'm going to put my little times there. And again, she has to roll double 4s. So the first time she's got to get 1 out of 6. And again, there are only 1 4 on the second dice as well. So that's also 1 out of 6. So now I'm going to multiply. 1 times 1 is 1. 6 times 6 is 36. So my probability of this happening, of her winning the game, is 1 out of 36. That's not very good chances because 35 times she will not win the game and only 1 time she can win the game. So let's take a look at the next one. Kim will flip a coin and roll a number cube. What is the probability that she will flip tails and roll a number greater than 4? So again, I'm going to take my two events and I'm going to multiply them together. So what is the probability she will flip tails? Well, if I'm looking at a coin, it has 2 sides, and only one of them has tails. So that's 1 out of 2. And again, I'm going to multiply them together. So I'm going to put down my little multiplication symbol. And then I'm going to see, it says a number that is greater than 4. So if I'm looking at a dice, how many numbers are on it that are greater than 4? Well, 1's not, 2's not, 3 is not. 4 is not greater than 4. It is exactly 4, so that won't work. Only 5 and 6 are greater than 4. So that's 2 out of 6. 2 out of the 6 are greater than 4, so those are what we call favorable outcomes. 2 favorable outcomes out of the total outcomes. So now I'm going to multiply them across. Now, of course, you could take 2 6 and then reduce it ahead of time, or you can multiply and reduce at the end. Either way, it doesn't matter. I'm going to multiply first and then reduce, but again, you could reduce first and then multiply. Either way is correct. So 1 times 2 is 2. 2 times 6 is 12, so that gives me 2/12, but then I have to reduce it. 2 goes into 2 one time, 2 goes into 12 6 times, so my answer is 1/6. It is very important that I always write my answer, as a fraction anyway, in simplest form. Sometimes I can show my probability as a percent or as a decimal because I can always convert fractions to decimals and percents. But if I'm writing it in a fraction and the problem asks me to write it in a fraction, I need to make sure that I write it in simplest form. Let's take a look at example B. Here we are at example B, and Tom has a box of donuts. 6 are jelly, 2 are peanut, and 4 are chocolate. What is the probability that Tom picks a jelly donut, eats the donut, and then picks another jelly donut? So again, just like last time, we're going to figure out each of our probabilities and multiply them together. However, we have a bit of a problem here, and we're going to talk about that as we go through it. So the first one is that Tom picks a jelly donut. So let's take a look. We've got 6 of the 12 donuts are jelly. So I'm going to write that as 6 out of 12. Now again, I could reduce that ahead of time, but I'm going to just leave it as 6 out of 12 so that I know we're talking about 12 total donuts in the box, and 6 of them are jelly. Now the next one, it says he eats the donut and then picks another jelly donut. So that's going to be a problem because one of the donuts total is gone because he ate it. But not just that, one of our jelly donuts is gone. So we have to reduce the number to show this happened. So since he ate one of our total donuts, that means that there are only 11 donuts left in the box. And since he ate one of our jelly donuts, there aren't 6 anymore to choose from. There are only 5. So our next fraction has to be 5/11ths. So again, we have 5 because he ate the donut. He ate a jelly donut. And we only have 11 in the box because he ate that first jelly donut. So we're going to multiply them together. And we got 6 times 5, which is 30. 12 times 11 is 132. And I get 30 over 132. And you're thinking to yourself, man, that's a really big fraction. But again, you're going to reduce it. And when we reduce it, down to 5/22. Now, I do want to show you that if you reduce the 6/12 to start to 1/2, because 6 out of 12 is a half, when you do that, if you do 1/2 times 5/11ths, you still get 5/22. So either way, you end up with the same answer, whether you reduce ahead of time or whether you reduce at the end, assuming that you do both simplifications correctly. So let's take a look at the second one. In the second one, Michelle has 4 cards, 1 blue, 1 green, and 2 red. What is the probability that Michelle will pick a green card, set it aside, and then pick a red card? So we're going to take a look at the first thing that she's going to pick is a green card. So 1 out of the green cards, out of the 4 of them, is green, so I've got 1 out of 4. Then again, we're going to be multiplying times whatever our second one is. She sets it aside. So since she set it aside now, we don't have 4 cards anymore. We only have 3. But she is going to pick a red card. Now, she's not picking a green one, so our green cards don't drop down from 1 to 0. Since we have 2 red cards, that's 2 out of the 3 remaining cards. So I'm going to multiply those across. 1 times 2 is 2. 4 times 3 is 12, so I get 2 over 12. But again, I'm going to write this in simplest form, and that's going to be 1/6. Let's take a look at some practice problems. Okay, you know everything you need to know about finding independent and dependent events. I want you to try these 2 practice problems on your own. Then remember to show them to your teacher to see if you get them correct. This brings us to the end of the video, however, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub. We'll see you in the next one.